Hi everyone, so we've come to the last question in the June 2024 CSEC Add Math Paper, which is on probability and statistics. So in this question, we have a stem and leaf diagram which represents the scores out of 80 of students in an Add Math exam. So part A, we have to write the raw data set that was used to construct the diagram above, and that was worth 2 marks. Okay, so since this is all stem and leaf, they didn't give us a key. But since it represents scores out of 80, we would assume that this stem represents the tens column in the values, and the leaves represent the units, digits in each value. Okay, so therefore, if we were to write out the raw data values, then the first value would be 30, then you have 33, etc. Okay, so, and of course, the last value will be 79. So these are the values, raw data values that we've written out from the stem and leaf. So let's go on to part B. So part B, determine the following measures for the data set. Right, for 2 marks each, the median, mean, and the mode. Okay, so for the median, so for stem and leaf diagram, what I teach my students is next to each leaf, we just write down the frequency for each stem. So for the first stem, we have 3 values. So this is frequency. All right, next we have 5, then 4, then 3, then 2. And next to that, we could also write in the cumulative frequency. So we have 3, 3 and 5, 8, 8 and 4, 12, 12 and 3, 15, 15 and 2, 17. So when we have to find the median, it gives us an easier way to find the median value. All right, so since there are 17 values in all, median, which is Q2, would be half of the 17 plus 1th value. So 17 and 1 is 18. Half of 18 is 9. So we're looking for the 9th value. Okay, so according to our cumulative frequency column, the 3rd value would be 37. The 8th value would be 49. So we are looking for the 9th value. So the 9th value would be, therefore, 51. Now, very clearly, you could actually count it out on your own because it's not a lot of data, right? So you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, and you would still get 51, right? But I think this makes it a little easier, of course, when you have a large set of data. So let's find the mean. Of course, the mean exam score, we'll have to add up all the values and divide by 23. So x bar, or mean, would be sigma x over n, of course, because this is raw data. So when I added up all the raw data values on my calculator, I got 885. And of course, my total number of values is 23. Sorry, why am I saying 23? 17. So therefore, 885 divided by 17 gives approximately 52. So the last part, part 3, the modal score for 2 marks. So of course, the mode will be the value that occurs most frequently. And if we look at it, this data set actually has 2 modes because 53 occurs twice and 67 also occurs twice. Right, so the modal score or scores, see that's why they have S in brackets because it's actually 2 scores that are in mode. So therefore the 2 modes are 53 and 67. And let's go on to Part 4, which is the last part of part A of this question, given that for the data set sigma x squared is 48,999 and sigma x is 885, find the standard deviation of the data set using this formula. So the formula they gave you, s is equal to the square root of sigma x squared minus sigma x squared over n all over n minus 1. Okay, so it's just with 4 marks, but of course we have to show all working. So let's substitute the values that we have. Sigma x squared is 48,999 minus sigma x is 885, so that's 885, and of course we're squaring that and dividing it by n. N in this case is 17, and then we're dividing all of that by n minus 1. Okay, so let's work this out step by step. Of course, that's why it's 4 marks. So we have 48,999. Let's work out 885 squared. That's 783,225. I'm going to divide that one time by 17. Okay, so I get 46,072. Okay, I'm going to round it off to the nearest whole number. And of course, 17 take away 1 is 16. Okay, and remember I'm finding the square root of all of that. So, next step, 48,999 minus 46,072 will give 2927. We divide that by 16. Okay, so that will be the square root of 182.9375. I'll use the whole number on the calculator. So square root of that will give me 13.5. Alright, I'll state my answer to 1 decimal place. Okay, so that is our value for our standard deviation.